Hello, I'm Iain Betson from Real Resilience, and I welcome you to this first of what I hope will be many webinars on tape and tape recording. The content of this first webinar is on performing an audio lineup on your machine. We will be covering the basics from the record and replay side of the machine, also the preliminaries of getting the machine ready prior to doing that. I sent you some information via email earlier, and I thank you very much for booking a ticket to receive that information. So I hope you've got some confidence in the person who's standing here in front of you now. Now, the techniques we'll be covering in this webinar are applicable to the audio lineup of any tape machine, whether it's a quarter inch mono machine or a 24-track 2-inch machine. All of those techniques are applicable. Even if you've got a cassette deck as well, we can apply some of those techniques. We are working on a Tascam 32 tape machine. It's one of those from my collection, and I've decided to select this because it's got a few functions on that are perhaps different to the normal, one of which if you've got a Tascam, a BR20 or indeed a 32, you'll see it's got a sync function on it, which not many 2-track machines have, so that's one of the reasons why I selected it, so perhaps we could talk about that. It's a quarter inch, as I said, a 3-head erase, record and replay stereo machine. So this is what we will be using in the webinar today. Now, before you do an audio lineup, you need to make sure that the machine is handling the tape properly. So put some old tape on, and I do stress this, tape that is not going to suffer if the machine decides to, so we say, throw a wobbly. So we can put it into rewind. We can put the machine straight into fast forward, give the machine a little bit of a workout, put it into rewind, get it up to speed, and one of the hardest tests you can do for a tape machine is go straight into play. It's got to slow the tape down, reverse the direction, and bring the pinch roller into the tape, all without snagging the tape. So once you're happy that your tape machine is handling the tape okay, you can move on to the preliminaries prior to doing the actual audio lineup. What I mean by that is cleaning the heads and demagging. Now, rather than me standing here and explain it to you, I've made a video and we'll watch that now.
Prior to the audio lineup, you will need to carry out some preparation of the tape recorder and assemble the required tools. Some of these items are easily available and quite cheap, whilst others are specialist items and, I'm afraid, can be expensive. First, let's look at what we require in the way of kit. A demagnetizer for the heads, adjustment tools for the audio amplifier trim pots and for setting the head azimuths, solvent and cotton buds for cleaning the tape path, a suitable cleaner for the pinch roller, a line-up tape for setting up the replay chain, a means to measure the audio replay levels, a tone generator to create audio signals to record with, an oscilloscope or suitable meter to adjust the head azimuths, a sample of recording tape you will set the machine up for. You will also need the appropriate leads to connect the tape recorder to the measuring set, tone generator and oscilloscope. In this video we are using a Studer A820 2-track machine to illustrate the tape path cleaning and head demagging process. Although a high-end machine, the principles shown here are applicable to all recorders of whatever sophistication and size. If not already done so, it is recommended that you switch the machine off now. It is accepted that keeping the machine powered can be useful in rotating the capstan to aid cleaning it, but in doing so runs the risk of forgetting it's switched on when it comes to the demagging process. With the cleaning solvent and cotton buds, in a logical fashion, clean the rollers, guides and the heads of oxide and binder deposits. With the increased likelihood of older tapes being played on machines, some of which will be suffering from sticky shed syndrome, the chances of large deposits of oxide and binder being stuck on other parts of the tape path are high. The cleaner I use is isopropyl alcohol in a spray can. It's reasonably cheap and is ideal for the job. As for cotton buds, ones from the local pharmacy are ideal. You will get through a few when cleaning, so it's not worth spending a lot on these. If the heads and rollers are heavily soiled, you may need to resort to using a paper towel as an applicant. Use only single-use types, as you don't want to run the risk of a repeated use cloth picking up anything that could scratch the heads or rollers. Any kitchen roll wipe will be fine. If there are some tough to remove deposits, usually tape binder, I use one of the cotton bud sticks with the bud removed, and this will do the job. Never use anything metal such as a screwdriver to scrape the deposit off. More solvent and rubbing with a wipe is the only method to use. After cleaning the tape path, clean the pinch roller. Do not use isopropyl alcohol to clean this, as with repeated applications it will damage it. In this video I am using a detergent-based liquid from Technics, but I now use a copier and print roller cleaner, which is much better. The brand I use is called Platen Cleaner and is readily available online for minimal cost. Demagging the heads. Like headwear, again, don't get overly concerned about when to demag. I do this on every machine I service, as I don't know when it was last done. But on your machine, where its history is known, even with regular use, demagging every 3 months should be a suitable interval. When you do demag, care must be taken to do it properly, or there is a chance you will damage the heads and the audio electronics. The machine must be switched off. Failure to do so will mean the large amount of magnetic flux created by the demagger will overdrive the record, replay and erase amps and could damage them. The demagger should not be switched on or off near any heads. Doing so runs the risk of permanently magnetizing the head. Switch the demagger on well away from the machine and using a circular motion, like waving a magic wand, bring the demagger tip up close to, but not touching the heads. Keep the demagger moving with small circular motions and move on to the next head until they are all done. When you've finished, slowly take the demagger away from the heads using the circular motions and switch it off away from the machine.
I hope you got the information there for cleaning the heads, cleaning the pinch roller and demagging the heads afterwards. This, just to recap, is what I use to clean the pinch rollers. Platen Clean. It's about $3 a tin. I buy it online and it just comes in a pump can. Put it on a bit of single-use wipe or your cotton bud and clean the heads with that. If the head's really soiled, I do take it off the machine and with the wipe clean the head by hand that way. You saw me using the IPA, isopropyl alcohol spray can. This is the stuff I use. Again, it's available online, not very expensive. It's probably about $2, $2.50 for a tin of this. I did see a debate recently on Facebook amongst the groups as to whether 99% or 91% isopropyl alcohol was the right thing to use for your heads. Frankly, I'm too busy playing with my tape machines and using them to worry about that 8% difference. Quite honestly, that kind of level, 91% almost pure alcohol is perfectly okay. And as I said, if the heads are really soiled, you just really got to get in there and clean them off with your cotton buds and your wipes. The demagger, the one you saw me using there, is this one. Rather an old beast. Is ideal for 1/4-inch heads. Strangely enough though, I don't know why the manufacturer just fitted the metal rod with no covering at all on it, so I put a plastic covering on it here, and I would urge you, if you have got a demagger, to make sure there's no metal parts exposed, because you don't want to run the risk of scraping them against the heads. That's just doesn't bear thinking about, really. Incidentally, don't use the small cassette based demaggers that you might find. They are just not up to the job. Okay, for cassettes they are, but not even for 1/4-inch heads. And I'd also say that this is probably not up to the job for a 2-inch head. I have a larger demagger. Handymag's a good make. You can get those online, as you can get everything nowadays, and that is quite man enough for the job to demag those larger heads. What we need to do afterwards is obviously connect it up an air test kit, which you saw me using in the video. This is how I've connected the equipment up. We have a tape machine in the middle, the oscillator that generates our tones for the recording side, and on the opposite side there, a level meter, so we know the levels that are coming off the tape, an oscilloscope to do the azimuth, and a means to monitor the audio that's coming off the heads. So you will need the appropriate leads that come out of your oscillator into your machine, out of your machine, and also to split the signal out to the level meter and the scope. I use a passive splitter box that I got from a studio suppliers, and I know it doesn't affect the level coming out to the measuring units. In other words, when I plug the oscillator to the output as well as a level meter, it's not what we call loading the signal down and giving me a false reading. So do bear that in mind. My audio kit as well, which I'll talk about in just a second, also has a built-in audio monitor. You might want to use the speaker on some machines that is built into the machine. Some professional machines have a built-in speaker which allows you to listen to the audio both going into the machine and coming off of it. If we look at the audio lineup kit that I use, yes, we need an oscilloscope. This isn't an expensive scope. It's a base model. It's probably about $150. It goes up to apparently 25 megahertz, it says there, which is ideal if we are setting the audio up for bats perhaps, but quite honestly it's fine. It's even good for checking, if you need to, the oscillator frequency. Although you won't hear it, you can use a scope just to make sure that your oscillator frequency for your bias and arrays, if you're getting that far, you're really probably getting away from an audio lineup now, but you could use this scope to check that. My two audio test units here, these are the Lindos LA100 set, and I would say they are, I mean, I'm using equipment here because I am taking clients' machines and lining them up, and I need to know the machines are working to the best they can. So I have a professional quality test kit. Lindos LA100 test set. The bottom unit is the oscillator. It both gives me the frequency and the level it's sending out. And then I have the measuring set at the top with a built-in speaker at the top, which can check the level. I do appreciate that this kind of equipment is probably out of the range of many, and I would not expect you to invest in such, especially if you only really want to do the odd occasional lineup on your machine or your collections of machines. I am working on a switch box and leads using a digital voltmeter, which I plan to sort of roll out this year. And the idea behind that is using the freely available oscillator programs, even on your phone, you can get them now, or just based on a PC or a Mac, to create the required tones, and then using a digital voltmeter to check the levels. And you can get oscilloscope programs on a PC nowadays, which are reasonably okay. Really, all you're using the scope is to make sure the phase, what we call the phase of the signal, is okay. You're not using it for precise measurement. So you could even use one of those oscilloscope programs on a laptop. The downside is, with those laptop oscillators, although you know the frequency they're creating, you don't know the level that you're sending to the tape machine, and that is crucial, and we're going to be talking about that a little bit later. You need to know the level you're sending in, so how else do you know if you're recording the correct level onto tape? And that is a problem with those PC units, and so I'm developing a switch box which will allow you to switch the voltmeter to the output of the oscillator to check the level, and then easily switch it back so it routes it back to the machine and to the output of the tape machine. You can play the tones that you require and use the digital voltmeter to check your levels that way. Let's just move on to the audio lineup itself, a replay lineup. That's what the whole crux of this webinar is. If we just move on to our record, replay, erase chain of a tape machine. I'm not expecting you to learn this, there's no tests, but it is the basics of what goes on inside any tape machine. And this I'm showing you is one complete channel, from the input to the output and the oscillator, which would handle the bias and the arrays. A tape here is going from the right hand side down to the on the right hand side from top to bottom, past the three heads. The tape meets the arrays head, as we all know. It is driven by the arrays level amplifier here, working our way back is the oscillator, which also creates the bias signal. Bias is added on the record side. It's a frequency of about 150 kilohertz. You won't hear it, and due to the magic of magnetic recording, it actually disappears on the replay side. It's fantastic. But as I said, it also drives the arrays level amp and uses brute force recording, brute force magnetic erasure, just to wipe the tape. Going to jump down to the bottom here and find the replay head. The audio comes off the replay head. Don't worry too much about this item here in the green. If I just put it on the screen so you can see that in a bit more detail, the item that's circled there, it says sync and replay. This is why I chose a Tascam 32 machine, because it does have that. If you have got a professional multi-track machine, or even semi-professional machine, a 4, 8 or 16, 24 track machine, you will find the sync function on there, because it is used in music recording. But normal 2-track machines, your Revox A77, B77s, or your TX or Akai's will not have a sync output on them, a sync switch and sync function on them. The audio comes off the replay head. Let's assume the switch is in the replay position as it is in the diagram. It goes to EQ, equalization. This is basically tone controls if you have on your amplifier, your bass and treble. But unfortunately, this is where we start getting into the real sort of granularity, the real grunt of audio lineups on tape machines. I wish it was just putting a few tones on a machine, making sure they're at the right level and replaying them. The EQ amp deals with what's called the equalization curve. You might have heard NAB, IEC, CCIR. This thing is the thing that's dealing with the audio that's coming off the head. The reason being is magnetic recording is inherently non-linear. I wish it was, which means if it was linear, the low frequencies will be exactly the same as the high ones. They're not, and we have to compensate for that. Some are higher, some are lower, using the equalization curve and the EQ amp. You will see that on the front of your machine with it could be called a treble control or HF or high. It then moves on to the replay level. That's this is the replay amp. So this is the actual level coming off the tape. So we make sure it's at the prescribed level coming there. And then finally it gets to the line out level on before it leaves the output. If I just switch back to my tape machine here, we've got 2 controls on the front. This is the input and the output control. You might have on your machine functions that say cal or uncal. Perhaps if you're lucky and you've got a Studer with an overbridge on it and it's got some large recording controls, and there'll be a cal and uncal button. Well, you have these line out amps, and on some machines, such as a Revox B77, they're actually around the back of the machine. But if you're on your Studers, they are buried in the machine. But you do have a control over them. This arrow here on each of these little triangles is to show it's a volume control. You do have control over them to set the output level, the final output level coming out of the machine and going off to your other equipment. Let's go to the middle area, the input here, which we will be coming on to when we do the record side, but we do have to consider it on the replay. Audio comes in, it's going into a line level. You saw on my Tascam there I had a line level control. You'll find your cal and uncal controls on your machine that you can adjust the line in level. It's probably what you use to control the record level to make your VU meters waggle to the right level. The audio is then sent to the record amp, but let's just leave it there and pop down to this line here that says source and tape. On my Tascam it says input and repro. You might find it called rep and rec. It's the same thing, source and tape. Source is their input signal and tape is obviously the audio coming off the tape. I have had a client say, oh, my audio sounds very good in the source position, but when I put it to the tape position it sounds less than best. Well, if you realise all you're doing here is you're sending the audio into the machine through the line-in amp and looping it back out to the line-out amp, which has proved that your line-in and line-out amplifiers are very good, but what you're not doing is sending the audio the long path through the tape and back out. So this is the difference between your source and tape switch. Some source and tape switches will work on the output, as this diagram does here. So in other words, it will ignore what's coming off the tape and loop the output, the input I should say, to the output. Other source and tape switches perhaps will only work on a monitoring switch, perhaps to a set of headphones or an external speaker. It depends on your machine. Popping up back here to a record level, this is the amp analogous to the replay level. That's the amp we're going to use to adjust the amount of magnetic flux, magnetic stuff that we put onto the tape. Our equalization does the opposite job to the equalization here, NAB and IEC equalization curves. And then it meets this cross here, and it's finding that it's meeting the bias signal, 150 kilohertz signal. I'll come on to what bias does towards the end of this webinar, but it meets the bias signal, and the two are just joined together. You might have heard fancy terms like modulation or anything. It does nothing like that. The two signals are just glued together, 150 kilohertz signal with your audio, which is probably anything from 20 hertz up to about 15 to 18 kilohertz, just sort of mixed in with it. It goes to a record drive, and it's finally popped out onto the record head. Let's just cover the sync control here, because although it's not vital to a tape lineup, you might well need to know about it if you're working professionally with your machines in a multi-track machine. If we imagine you are using your multi-track machine to record some music, it's say a 4-track machine, and you've recorded on tracks 1 and 2 some guitars, and you then want to record your voice singing along to those guitars onto say track 3. Well, the problem you've got, if you can see here, that if you replay the machine without the sync function, you are going to be hearing those guitars delayed as they come out of the replay head. The tape's coming down, you hear the guitars here, and you sing in time with them. But your audio is then popped onto the record head above it. You will always be late, in that you will never be in time with the guitars that you're singing along to. What the sync head does, it allows you onto tracks 1 and 2, which we recorded their guitars, to put the record head as a replay head. It switches its function to act as a replay head, but only on those 2 tracks. On track 3, where you're recording still, it's still acting as a record head. So as the tape comes down here, you've got tracks 1 and 2 whizzing off down here to the output, and you can hear them to sing along. You sing along, and it's recorded on track 3. That's the essence of sync, and it gets over that delay problem. Now, we can finally move on to a tape machine, and we can start talking about some levels and getting some levels onto the tape and off of it. You saw in the video some line-up tapes. These are some of my line-up tapes from Magnetic Research Laboratories in the States. I have had people asking me, how do I create my own line-up tape? My strong advice is don't. I will really go away and trust MRL. I've got no financial link with them, but they have been making tapes since the dinosaurs ruled the earth, and they do know what they're doing. I'm sure there are other lineup tape manufacturers out there somewhere, but I did do a Google search for this webinar and I couldn't find any. But as I said in the video, some items are expensive and some are quite cheap, and I'm afraid line-up tapes are not the cheapest things in the world. These two are for 1/4 inch, one is for 7.5 ips, one is for 15, and each one of those cost me about $150. I'm in the UK, so I had to pay import duty and shipping. If you're in the States, you might get them a bit cheaper, but you will still, if you're outside the continental US, you are going to pay for them. So about $150. Perhaps if you're in the US, you might get them a bit cheaper. This one is a 1/2 inch tape, and I have to say it's a nice big fat 10.5 inch reel, but you don't actually get much for your money there. There we are, that's the line-up tape itself. It's not even a full reel. That cost me over $500, and I have just bought a 1 inch tape, which was nearly $800, and I have a 2 inch tape on the way, which is into 4 figures. So unfortunately, you have to take a deep breath if you are going to invest in the line-up tapes, which is one of the reasons why I said earlier, make sure your machine is performing mechanically to the best that it can before you put any of those precious tapes on them. The other thing to look at with these things is that good old MRL, I believe you have to go on a 2-week training course to understand the catalogue numbers. I just do not understand them at all. I usually get my local distributor here in the UK to sort that out for me. All I tell them is I want a 1/4 inch tape for 7.5 ips or 15. I believe they do a tape which will do both speeds, and indeed 3 3/4. I believe they do those on a single tape. The downside is you will not get a full range of tones and other things. It's kind of like a short form tape. So I wanted 2 tapes, 7.5 and 15. I also wanted them for the IEC equalization standard, and I'm going to cover equalization standards in a minute, because there's also NAB equalization, which you have to have for your particular machine if you're going to line it up. So I've got those things to consider, what speed I'm lining up, and what equalization curve I will be doing. There's other terms as well, things like fringe compensated. I really can't go into those, but I do recommend that you go onto the MRL website. It's a lot of text, but if you're into that good sort of late night reading, you can find all out about the lineup tape that you need. I'd like to pop back before we move on to actually playing these tapes, in the fact that one of the things we have to do, drawing your attention, is to the input line in level source tape switch to line out, bottom left hand of the diagram. What we need to do before we can put any pre-recorded tape on the machine, which replay here, a line-up tape, we need to know if this line-out amp and line-in amplifier are at the levels we expect. So what levels are they? The first thing you should do, get the manual for your machine. This is the Tascam 32 manual. It's a PDF. Go to Hi-Fi Engine. Again, I've got no connection with them. It's a free to apply for account. I think you're limited to about 5 documents a day to download, and there is a massive repository of manuals there. Get the manual. I did put in the preliminary email I sent you that even if you haven't got a Tascam, download the 32 or 34, 38 manual. There's some great stuff in there about the theory of tape machines. It's just nothing to do with their machine. It's just the theory, and it's a really good read if you want to know more about it. So I would recommend it. But read the manual and make the notes. You will find in this manual, and this is where we start to get into a little bit of I would say not swamp, but it can be heavy going, and I do apologise for that, but I'm afraid we have to cover it. You are going to find terms in that manual that relate to things like dBs, dBUs, dBVs, we'll find millivolts, and we'll find nanovabors per meter, NWB/M, nanovabors per meter. It's magnetic flux. It's stuff it's effectively the magnetism that goes on the tape. There is a definition of magnetic flux, and it's all to do with the depth and the perpendicular space and the depth that the magnetism penetrates to. Way outside this webinar, but you do have to take that into account as to how much magnetic stuff, how much magnetic flux going to our lineup tapes here. Magnetic flux is on our lineup tape. This one tells me that there's 250 nanovabors per meter magnetic flux on the tapes, so on this tape. So you do have to know that. That's an additional thing that you'll have to know for your lineup tape when you select it. But before we ever get into their magnetic flux, we need to know how many dBu or how many dBV, and there's two versions of dB I'm going to have to cover, that we are sending into our machine. Now, if we go to my Tascam machine, this I know is a European model, and it's an IEC equalization curve. If you're in the US, you might have a machine. If Tascam designed it for the US export market, it might be an NAB machine. So we need to know what the equalization is of the machine. We also need to know from the manufacturer what their terms or their dB terms are in the machine, and that can only come around through through reading the manual. I know that my Tascam uses dBVs. That's the unit that it the audio unit that it uses in its lineup and in its operation. But what is a dB? A dB is not like a volt, where a volt is 1 volt and it's a known quantity, or 10 degrees centigrade, 15 degrees Fahrenheit. A dB is something that can be relative to any of the actual finite figure of voltage, or indeed it's used in many other things such as sound pressure levels that really we want it to be. So what do I mean by that? Well, dB, the B in dB is Bell, and it was created by Bell Laboratories in the States, and they wanted a way of checking the quality of their phone lines. An example, they wanted to send a telephone call in from one end of the country, and they wanted to know what the quality like was at the end, the other end of it. Was it louder? Was it quieter? They decided that they would a dB would be all tied up with human hearing, and whether it, and the actions of the ear. So they decided if they sent, say, a signal in at 1 volt, a known level, and it came out at 1 volt at the other end, that was 0 dB. There was no change. If it came out at 2 volts, that was a plus dB. If it came out at half a volt, that was a minus dB. So in other words, the dB could be whatever it was. If they put that signal in originally at 2 volts and it came out at 2 volts, that was 0 dB. If it came out at 3 volts, that was plus dB. If it came out at 1 volt, that was minus dB. You can see our dB is kind of moving up and down the scale of our voltage or our sound pressure levels, or what we're deciding to apply it to. The next thing I mentioned, we put 1 volt in and we get 2 volts out. That isn't 2 dBs increase. That is 6 dB. Yes, I know if you know your dBs, there are occasions where a doubling of the voltage or a doubling of the measured signal is only 3 dB, but in the vast majority, a doubling of the original signal is a 6 dB increase. So we put 1 volt in at 0 dB, it comes out at 2 volts, that's plus 6 dB. Now, if you can guess what happens at the other side, we put 1 volt in and it comes out at half a volt, that's minus 6 dB. Every doubling or halving we have, we add or take 6 dBs off. So if it comes out at 4 volts, in other words, a doubling again from 1 volt to 2 volts to 4 volts, that's 12 dBs. If it's half a volt and goes down to a quarter volt, that is minus 12 dBs. Now they have decided that the dB in this case, and Tascam have decided with their machine, that they will call that 0 dB is equal to 1 volt, dBV, which was fine for older equipment, sort of pre-1950s. As audio electronics came along, and again, I don't want to bamboozle you too much, but they decided that high impedance and equipment with very high impedance was better than the lower impedance equipment they were using on the telephone lines in the 1930s. And audio equipment will have a low output impedance. Don't worry about the impedance and don't worry too much about this, but this is what they've decided. But that means, if you might be thinking a bit strange, why if it's high impedance, that's high resistance, the signal's fighting against it? Believe me, it isn't. It likes high impedance. It's less resistance really for the signal to go through. It might seem perverse, but it is. So they realised that if they put 1 volt in at 1 dBV, it didn't actually come out at 1 volt. It came out at something slightly higher because there was less resistance in the electronic circuitry to the signal. So it was decided to create the dBu. Some people say the U stands for unterminated. I'm not entirely sure, but it's called a dBu. And that has been decided that 0 dBu isn't 1 volt, it's 0.775 of a volt. A lot of people, if they're working in broadcast, will understand what 0 dBu is, 0.775 of a volt. As an ex-BBC engineer, that's kind of been ingrained into my head, and various meters will tell us, oh, that's ppm4, that's 0 dBu, that's 0.775 a volt. So why am I telling you all this? Well, the problem we have is that Tascam have designed my machine with dBVs. My test kit is set up for dBUs, so I have to do a conversion for them. I am used to dealing with more dBUs, the test tapes, and it's just something I said that's been ingrained in me, so I'm sure I could reset the machine, but then I'll be doing it all the time. I just prefer to do the conversion. So this is what I'm saying is when you start seeing what these dBUs are in your manual, you might need to get a pen and paper out and work them out. Let's move our slide on here. I draw your attention to the 2 columns there, that one say dBV RMS voltage, and the next one along to the right, dBu RMS voltage. There's the red, dBV in red, dBu in blue. Scan the way down, and as you can see, dBV 0 equal to 1 volt, and a couple of lines below it on the right hand side, dBu 0.775 of a volt. Again, I'm not expecting you to learn all this, but I will provide this for you because it's a handy way to do your conversions. Incidentally, if you look on my website, realresilience.co.uk, there is a link section, and in there you will find a handy dBu, dBV and millivolts conversion routine. It's great. You just type in the number that you start with, perhaps it's listed in the manual, and it'll give you the other things that you want. We have to start at nominal lineup levels. What level is the machine normally working at? Tascam, with its 32, tell me in the manual that it is minus 10 dBV, which is equivalent of, if we go back to our chart here, halfway down the green line there, minus 10 dBV is 0.3 of a volt. I hope you can see that, the green line there that's highlighted that says 250, the top green line, and on the right hand side, Tascam reproduce calibration. That is what they tell us, that is what you should be putting in your nominal level. And incidentally, that's a level they'd also say you should set their VU meters to as well. So that also answers another question, what levels of my VU meters should be set to? So we've covered that as well. Going back to my chart here, minus 10 dBV, which is 0.3 of a volt, is actually minus 8 dBu, which is also 0.3 of a volt. So I know from my test kit here, I am going to be putting in, and if you can see that down there, minus 8 dBu. I'm also putting it in, if you can see there, I don't know if the light's shining on it, 400 Hertz. Now that's the nominal frequency that Tascam tell me in the manual I should be lining the machine up for. Your machine might be different. Studas are usually 1 kilohertz. Again, that's something that's ingrained into me from my past BBC training. But in this case, the Tascam tell me it's 400 Hertz. You will hear some tones on this, and I'm going to play, and I hope you can, they don't interrupt too much, but they're there for illustrative purposes. Just going to take the mute button off the machine there. You can see that the scope is now showing a waveform. If I go to the machine itself, the VU meters I've already set up, they are set to 0 VU. I can set my controls to the level that Tascam tell me to set for their calibration. I'll just turn that off so we can, so it's not interrupting us too much. So I have set the levels here. Tascam tell me to set them to number 7. You might see I've made 2 little marks there. The manual told me to do that. I've set the input and output controls to 7. Your machine will tell you otherwise in the manual. I've also set the switch button here, a source tape switch in Tascam terminology, to input. So the signal is coming into the machine. It is then looping round the in the line in amps, looping round through a source tape switch and back out. So if I go back to the tone again, I hope you can hear that, and my test kit here, you will see at the top level there, I'm injecting minus 8 and I'm getting minus 8. You might see the minus 10 there, but this is dBUs, minus 8 there. And I can adjust it. That is me adjusting the input level control away from our 0.7. Now, say I had made the adjustments for that Tascam tell me. I've set the controls to number 7. I'm injecting the levels that I know, and I'm not getting minus 8 or minus 10, depends on what your test kit's set up for. Or if you are using a digital voltmeter, the millivolts, your 0.3 of millivolt out of your system, what do you do about it? This is where you need to resort to the tweaks and getting your tweaking tool out to adjust them. In the case of the Tascam, I've got 2 boards down here. One's a record and replay board for the left channel, and the one below it is the record and replay board for the right channel. If I just hold this up to the camera, this is the panel that's coming off the back of it, and it's telling me what all the tweaks do. Tweakers. Got to talk about those before we get into adjusting either of those boards. The normal thing you would use would be one of these. This is a blue plastic tweaker. I don't know whether you can see that there. It's got a metal adjustment end on it, and it's ideal for the job. 99.9% of trim pots, tweak pots in the world will use this tweaker. All except the Tascam. It doesn't have those. The pots on here, down here, are either too big for the tweaker or too small. I am going to introduce you to something that maybe the purists will throw their arms up in horror, but sometimes needs must. You have to resort to other tools. A jeweler's screwdriver for the small ones. Note as well, if you can see that, I've actually put insulation tape around there. That's a golden rule. You must use insulated tools. Yes, a tweaker's got a metal end on it, but it's majority plastic. A jeweler's screwdriver isn't, but that's why I've insulated most of the metal with it. For two reasons. Firstly, I wouldn't want to be starting putting lumps of metal inside a live machine. You're bridging components and doing all sorts of nasty things and could blow it up and damage it. The second thing is that you are acting as another electronic path if you are using an uninsulated tool, and that kind of effect of putting noise on the audio or indeed just creating different levels. It can actually pull the level down. I've seen that do it in the past. If you adjust the tool with make the adjustment with an insulated tool, the level can actually drop, and you take the tool off and it will suddenly bounces back up again. Same as with the screwdriver. I'm having to use this for the larger adjustment to make it. I'm afraid that's the way it goes, but it's still an uninsulated one, and I'll be very careful with it. Let's put our tone back on there. Let's go back to our tape machine. We've made our adjustments, they're not quite right. You find the appropriate trim on your machine. In my case, the manual tells me to look for the input calibration trim pot. I've got my setting here, I'm looking at the left channel. If you can just see that, there's an L up there for left, and I'm adjusting that. There you are, you can see that going up and down. You can also see perhaps one of the waveforms changing. I'm adjusting that now, so I adjust that to -8, as the manual's told me, -8 dBu. So what we have done there now is that we have lined up the audio that goes line in amplifiers and line out amplifiers. We know the level that we are sending in and indeed getting out are what we expect. Anything else, other changes we make, will all be down to the record and replay amps. We can finally come on to actually playing a line-up tape. Now, I am not going to be using the MRL tapes, mainly because they are precious tapes and very expensive, and I reserve them for the clients' machines because they have to earn their keep. The BBC, of which I worked for that illustrious organisation for 10 years or so, they did away with tape in about 2000. That was about the last time they went to it, and they had a massive clear out. And guess who was near the skip when they threw a lot of it out? I'm going to be using some of the old BBC line-up tapes. And before we say, people say, oh, you're using an old line-up tape. These are recorded on Agfa Pen 468, which is zonal 675. And zonal made the tape to that recipe. BBC called it Type 200 tape. It's a very stable tape, very good and low. It doesn't suffer much from crosstalk. Doesn't suffer from sticky shed syndrome either. Very nice tapes. And although I don't use them on a day-to-day basis, they're perfectly good enough for what we need today. We have two tapes here. That's a 15 IPS, 38 centimeters per second. That's a 7.5 IPS, 19 centimeters per second tape. They're also IEC tapes. I don't know whether you can see on the back there, but it tells me there's IEC 35 microseconds. Don't worry about that microseconds bit. I do urge you to look at IEC lineup curves as to what a microsecond is. It refers to the different frequency what's called the turnover frequency or the shelving frequency of the lineup curve. Again, I'm trying to detective this as much as possible, but we do have to talk. About these things. These are IEC tapes. They're for IEC tapes for my Tascam machine, and I know I'm with the levels I play are going to be okay. So let's play air tape. You're going to hear a rather plummy BBC announcer. I think the poor guy's no longer with us. He's a good few years ago that he was recorded, back in the 1970s. And you'll hear some tones. There is a standard level tone which we can adjust, and then there is some frequencies, and then the azimuth.
1000 hertz.
And I hope this tone isn't too loud for you, but the machine, as you can see on the scope as well, is playing 1000 hertz of tone. Let's just stop that there. And what does that mean? What does that tell us? If I just go back to a diagram here on the PowerPoint, I mentioned that the MRL tapes were recorded at 250 nanovabers per meter, which incidentally, lucky for us, is the Tascam reproduce calibration level. We can see that on the right hand side. Tascam also mentioned a Tascam reference fluxivity level. It's the lower green level, and this is what they are saying. If you've got some of their tapes that are recorded at 185 nanovabers, there's that amount of magnetic stuff on the tapes, that's what they replay at. They will replay at, look at a red column, minus 13 dBV, or it will replay at minus 11 dBu. My BBC tapes here are recorded on the yellow level here. The BBC decided that it was nominal reproduce calibration would be 320 nanovabers per meter. This would correspond to 0 dBu. And then as they turn the level up, as they increase the level up to sort of plus 8, plus 12 dBu, there'd be more nanovabers. The maximum level the BBC decided when they recorded would be 1,000 nanovabers per meter onto the tape. Most tape machines, my Tascam 32 will take 1,500 nanovabers. So although we always love tape machines for that sound and that, especially in that Motown sound, that sort of crunchy sound that they had, that was called tape saturation. And if you were just recording saying the BBC decided its maximum levels would be 1,000, and Tascam are talking down at the level of, I think their level is about 640, and yet their machine will take 1,500, the chances of you putting the tape into saturation on these machines is very, very low, unless you really crank the levels up on the machine. Tape saturation, I'm afraid I'm going to have to gloss over that, but do look on my website. There's a handy glossary in one of the link sections which lists all of the many of the technical terms used in recording. So the BBC decided their level was going to be 320, which is their top band here. However, these tapes are recorded at 160 nanovaber, which is down here, which is 6 dB lower, 320 nanovaber to 160, that's half again, so we've got a 6 dB drop. So from the tapes I'm playing here, and as you can see the level here, I am expecting the VU meter on the Tascam to come at -4, and with my dBUs in the blue, I'm expecting it to replay at -12. So let's see if it does. Now I've set my nominal levels up, and as you can see, it's actually coming out at -12.39. I've already lined this machine up here. I'm sorry you can't read that type, it's very small, but -12.39 on my left channel. Just rewind it again. I need to adjust that. So what do I find? I go back to my tape trims on here, and I have one called Repo Cal for the particular speed. I must bear that in mind, because some machines, although the Tascam only has one control, certain professional machines will have a different level of control for the speed. That's just how they are constructed. So let's have a look at our machine. I'm going to put it into play again, and then I'm going to go to my Repo Cal and adjust it appropriately. So we make the adjustment here. I'm making the right one, and if you go back to my test kit here, you can see me making the change that I need to get it to -12 dBu. If you are buying a line-up tape, and especially if you've got a multi-track machine, get one with long tones on. The half-inch machine tape I've got there is about, I think it's about 2-minute long tones, because you'll be shuttling the tape backwards and forwards several times, trying to do track 1, track 2, track 10, track 12, and all the time you're shuttling that tape, you're risking damaging it. So do get yourself a tape with some longer tones on it. So that's the basics now. We've got the line-up level out. We know our line-in level, we know our line-out level. We've got the replay level sorted out. We need to know what the equalization is. Again, read your manual. What frequency should you be adjusting it? Bizarrely, Tascam talk about adjusting it for about 7 kilohertz, which is strange. I would adjust for about 10 kilohertz. Many professional piece of equipment, and indeed even the domestic like Akai machines, I would go for a 10 kilohertz control. But Tascam is saying their EQ adjustment is a frequency of 7 kilohertz. So I will find a near enough, I don't know if I recall on this tape, as whether there is a 7 kilohertz tone. There might be an 8 or a 6 kilohertz tone. We're into the band now of the line-up tones. I can see it's playing 12.5 kilohertz. You won't be hearing that at the moment.
10,000.
There we are. Plumbing Man's just told us he's playing a 10,000 kilohertz tone, which I'm going to use for the basis of this webinar to adjust the high frequency. The bands on this tape are only about 10 seconds long, so you have to be quite quick. One thing I would always, a bit of advice I suggest you do is know where the tweaker is and have all your test kits set up, then put the machine into play. The test kit might then settle down as it checks all the levels, but then if it takes too long, your bands run out, so you've got to be all set up for it. So what I am doing on my machine is I'm going to find the EQ control. It says repo EQ on it, low or high. That isn't frequency. Low or high refers to the speed of the machine. Low speed 7.5 IPS, high speed 15 IPS. The equalization curves will change. There are various equalization curves depending on the machine. Even if it's NAB or IEC, there are various equalization curves to take into account. Hence why on a machine we have Air 2 trims there. I'm at 15 IPS, so I'm looking at the high frequency one. I'm on my right channel, which is the control right the way down here. So I'll just get my tweaker ready, perhaps wind it back a bit. I'll go back to my, so you can see the kit here. Put the machine into 10,000 hertz. And there we are, it's coming in at minus 12.1, and there we are, there's me adjusting. You can see that on the oscilloscope, there's me adjusting it appropriately. And I adjust it for 12 kilohertz, minus 12 dBu. The idea behind that is that I am making the level at 1 kilohertz, a nominal line-up level, the same at 10 kilohertz. So the idea is we have a flat frequency response from low frequency to high. Depending on the sophistication of your amplifier, you can repeat that with some lower frequencies. A lot of the professional machines sometimes have a bass repo adjustment as well. My Tascam doesn't, so we can skip on that. But then you will be looking at probably 100 hertz. You would find the 100 hertz tone or something 125, for instance, on this lineup tape I'm using from the BBC. And you would adjust your bass control so it's as near enough or ideal at the same level as your 1K. I say near enough or ideal, bearing in mind we are dealing with A, machines that are a minimum 30 years old and have had a bit of a life, and B, this is analog magnetic recording. We are very tuned nowadays to digital being bang on, 90 some odd signal to noise ratio, flat frequency response to 22 kilohertz, ideal for your dog if it wants to listen. And we can then get very almost uptight. It's down by half a dB, it's down by a dB. Manufacturer spread on this Tascam is plus and minus 3 dBs across the spectrum. So in other words, I could have 0 dB at 1K and I could have 3 dB up at 10K, and according to Tascam spec, that's Tascam's design, that's still in specification. So we have to accept these anomalies now that analog audio recording is not perfect. We aim to get it as best we can, but sometimes, yeah, I find half a dB down, it's the best I'm going to get. Or I get it bang on at 100 hertz, and then strangely enough at 250, it's gone high. We have to make some certain compromises. So that's what you'll do. You repeat that for your bass signal. We need to do azimuth now. There's a band on this machine, which I'm just going to find. So what's he talking about? 12.5 kilohertz for azimuth adjustment. We adjust the azimuth on the machine using a high frequency. And we are adjusting the azimuth on the replay head, not on the record side. And you need the appropriate tool to do it. The appropriate tool for the Tascam is a screwdriver, amazingly enough. Certain other machines have like hex Allen key drivers, that kind of thing, but Tascam is just a screw head. If we look at our tape machine, here it is. You'll find it and check the manual. There is a screw head that will adjust the azimuth on the machine. So what is the azimuth? There's 4 adjustments for a record and replay head. Height speaks for itself. How high is the tape head relative to the tape? Azimuth. That is the rotational angle of the tape. We want to make sure that the 2 heads, those 2 sort of light rectangles in our head, are 90 degrees to the tape, or near as damn it, as it runs over the face of the head. Let's look at the center diagram. We're looking down on the head here. We can see our tape at the bottom. That's the wrap. Again, we want to make sure that the center of the head is at 90 degrees, or near as damn it, as it goes over, as the tape goes over it. Let's look on the right hand diagram here. We've talked about the height, that's on the right hand side. The zenith, that is, if you imagine the tape, we're looking side on at the head here. We've got the tape in front of you, and if the head is not angled correctly against the face of the tape. So if imagine if that's the tape, we're looking side on and the head is kind of an angle like that. We want to make sure both heads, the top and the bottom, left and right heads, are flat and against the tape, equal tension and pressure. So they are the head adjustments. You cannot do any other, well, you could do actually with a lot of faffing around, but you can't really do any other adjustment apart from azimuth using a test tape. You can do a thing called height and height wrap and zenith using a thing called paint and scrape. It's horrible. It involves painting ink on the head and then running leader tape over it to see what the scrape pattern is like. It makes an absolute mess of the tape or the heads, and it ruins the tape, and you have to clean all the stuff up afterwards. Or, as I do as well, use it with gauges on a solid block, and you can set on the head block, you can set those three adjustments up. Azimuth, you always do with a line-up tape. So, let's play our azimuth band. Hopefully you'll find
12.5 kilohertz.
It's the plumbing man and his 12.5 kilohertz azimuth adjustment signal. You'll see there's two traces on here, and they are the left and right signals. If I actually adjust the azimuth massively out, there we are, you see there's two waveforms appeared, two there. Now, the manual might tell you to do the X and Y method, and that involves putting the machine into a setting. If I press on my display and X, Y, and I think it's called the lithogist figure. What you're aiming to do is make that figure as thin as possible at the 45 degrees, and that means the azimuth is as best as you can get it as the tape moves across the head. However, I don't like using that method. I much prefer to use the twin waveform method. And here's the reason why. If I just show you, this is how I'm adjusting the azimuth. That is the peak. I know it's the peak because, as you can see, as I move it either side relative to each other, the waveform is dropping in level. That looks like it's in phase, but it's the wrong peak. If I adjust it and keep adjusting it until we get the peak, and I just, yep, that's the peak there, I much prefer to adjust it like this. And here's the reason why. Can you see that the waveforms are shaking slightly relative to each other? Imagine we've got a left channel and a right channel here, we've superimposed them, and they're actually kind of like doing this, and this is actually a result of the tape scraping over the heads. If you saw me cleaning that Studio A820 machine, azimuths on those absolutely rock solid, but then you're paying for a massively expensive high-end machine there with all those guides and rollers and all the electronics to sort it out, and it is superb. They are just literally superimposed. When I'm doing 820s, I have to check sometimes that I'm not actually listening to the source signal coming, or I'm injecting a signal and it's coming out the loop, and I'm not actually looking at what's coming off the head. But normally on most machines they're wobbling slightly like this. Now, yes, if you've got the lithogist figure, which is kind of like doing that, you know that as it does that, it's slightly going out of phase. Then you aim to get it as flat as possible. But what it doesn't tell you is if the head's, as the tape's scraping and fluctuating as it goes over the head, it might be like that. It might be as good as possible and it's just always wobbling that way or always wobbling that way. I like to have them so I can do, using the twin heads, to the two waveform method, is to know how much equally it's wobbling backwards and forwards relative to each other. And I set that up so yes, sometimes it's in plus phase, sometimes it's in negative phase. The lithogist figure only tells you that's as good as it can get. That doesn't tell you whether it's plus or negative phase. I just much prefer to use the twin waveform method. And as I said, I know I'm not on the right peak because I just wind it backwards and forwards until, yes, that's the maximum level. That is the right peak. And both of the waveforms are in phase as the tape goes over the head. Actually, this is a diagram to show you of the azimuth effect on the audio. We'll just quickly cover that. Top diagram, that's what we're aiming for. That's a head and air in blue, and the line is if we're adjusting it the way the head, the blue is the way the head would be picking it up, and the red line is our ideal. The lower diagram, as you can see, the head is twisted, the azimuth is out, and as you can see, the waveforms are not in line. Why do we worry too much about the azimuth? It has an effect if you're doing mono recordings and you sum them together. You can get phase cancellation problems as the two signals are not in phase and cancel each other out. But it's especially applicable if you've got a multi-track machine in the recording studio, especially a 2-inch machine. A little bit of phase error down here on track 1 and track 24 at the bottom, and then you start mixing that down. That can have actually quite bad phase errors, and funny effects start to come in. Maybe you want that as part of the recording process, but we're aiming for the ideal here. Replay lineup procedure. What we've gone through here, we've gone through the replay level, we've gone through our 10K level for EQ, we've gone through a level check just to make sure that the 10K hasn't adjusted their level, we've done our azimuth, and then I would check again at 10 kilohertz, find the 10 kilohertz or the 7 kilohertz in the case of the of Tascam wanting that in their manual, and just to check that the HF is still okay, and then do a final level check. And then the final thing you do, put some music on your machine. Make sure it sounds okay, and the music you put on, the pre-recorded tape you put on, make sure it's music you know, so you can have a critical listen to it. Do the lows sound okay? The bass signals? Do the highs sound all right? Does it sound okay? Does it sound what you would expect? If it doesn't, you might need to go around the loop again of this replay lineup using your lineup tape and make those adjustments to improve it. So that's the basics of the audio lineup side. Hello and welcome back to part 2 of this webinar from Real Resilience on the audio lineup of your tape machine. I hope you've got a lot out of part 1. There is a lot of information to impart. I'm afraid, as I said, I wish it was only just sticking tones into a machine and pressing play and getting them back off, but we are dealing with the physics and magnetics and mechanics of tape machine recording. I have changed the machine tape over to a tape that the BBC called their standard bias tape. So what do I mean by that? When I ask clients what tape formulation they'd like their machine lined up to, what I mean by that is, in the case of, I've just mentioned, their lineup tapes, Agfa Pen 468, Zonal 675, it's the same thing. Same thing incidentally as recording the Masters 468. It's a great formulation, I love it, and it's a tape that I know very, very well. Recording the Masters have tweaked it a little bit more. They've put a bit more rust into the recipe, a bit more glue, do whatever they do with the science and the chemistry, and they've created their 911 and 9, SM911 and 9 900 products. They will take a higher level than the 468, but the expense of crosstalk. One thing about the 468 is it doesn't suffer from print through, and if again I'll print through, please look at the glossary on a link on my website to find out what print through is. But it's if you're keeping tapes long term, print through is something you really want to avoid. There are other ways of doing it, things called storing the tape's tail out, but it doesn't stop print through, it just merely hides it. So the 468 was very good there. ATR, they use their quantity formulations, which is their I think it's a Grandmaster 456 recipe, I think ATR have taken. And also there's a third tape manufacturer that I found recently, which is spliceit.com. I think they're an American company, and they mentioned their Capture range of tapes. And then finally, we've got the older tapes, things like people say, well, I'm using Maxell or I'm using TDK. So I ask people, what tape do you want your machine lined up to? I have many of the modern tapes, and I have indeed some of the older tapes, but I don't have every one of them. So I ask them to supply a sample. You will need to do that if you're lining your machine up for a particular tape. And bearing in mind, it's a tape that you will record on. So I always say to people, if you're giving me this tape, you realise I'm going to be recording tones all over it. In the break, I've lined the machine up, so to put that on there, I put the machine into record ready. Your machine might not have that, but some machines will have a ready safe control. A77s, it's 2 buttons either side of the VU meters. PR99s, B77s, it's 2 switches. You will find a ready and a safe control, especially on the multi-track machines. You'll have that, so you know what machine, when you're doing your sync recording, you know what tracks will go into record and what don't. I put the machine into record. I've also put it into repo. So tape position, so when we feed signals in from my test unit, they are recorded on the record head, they then run through the erase head and back out. We have lined up our input and output levels. We did that earlier in the replay, so we can jump straight in and start doing our record level. Let's go back to my test kit. I'm going to put a nominal level in. We've discussed this enough, what the nominal level should be for your machine. In this case, it's 400 Hertz for our Tascam at -8 dBu, or if I'd read that, -10 dBV. As I put the machine into record and the tape runs through. If we look at the top level here, it's showing me that the replay level is -8.7 on our left channel and -8.28 on our right channel. So our right channel is pretty good, but I think our left channel is heading towards -9. That's not too good. So we find the tweak. We find the tweak on our board here, and the one I'm looking for is Rec Cal. So I find my Rec Cal control here on the right channel, which is the lower one. Let's pop back to our test kit here, and then if I adjust that, there you can see that the level is adjusting. See, there we are, the lower meters I'm turning down, and you might hear the level actually go up and down. So I'm adjusting that for the right level, which is a -8 as near as possible at their nominal signal or nominal frequency of 400 Hertz. And I can see there 8.01 dB. That's fine. Just going to rewind the tape back because we're using a lot of it up. Whatever tape you use, you can use a whole full reel if you wish. I do appreciate it's expensive stuff, or you can use a lesser amount as I've got here. You just have to rewind. Whatever you do, just make sure that the tape is in good condition, hasn't got any damage to it, because this is a tape you are going to be using to line up the record side, arguably the most important part of the machine, because if it puts rubbish onto the tape, it's going to replay rubbish. So we've done our levels there. We then go back to our record and replay erase chain, and I'm looking at these top bits here. We are coming on to talking about bias, and we are coming on to talking about our recording levels and the azimuth as well. And incidentally, the azimuth and the bias are interrelated. They do have an effect. So we need to adjust those. So what is bias? Bias is a high frequency signal that's come out from the oscillator. It's about 150 Hertz. You won't hear it, but it's mixed into the record signal in order to reduce distortion and make the signal a lot less distorted. The downside is it can also have an effect on the high frequencies. It's a compromise. And we need to do a thing called overbias. So if we just go to our record replay line-out procedure, I'm going to skip, due to time considerations, the azimuth. We are doing exactly the same, except this time with the record head. We'd be doing azimuth. All we do is we put in a high frequency, a 10 kilohertz signal. I'll tell you what level it is in a minute, because it's also related to the azimuth. We do our level check, we whiz down here, and we get to this triangle at the bottom here, our bias. We need to do that. So you do your level first. You do an EQ check just at 10k, because that's the frequency we're going to be using for our azimuth and our bias. So just make sure they're both the same level. When we display it on the oscilloscope, it means that they're nicely at the same level and easy to line. We can adjust the screwdriver setting on the azimuth tool, and we can see those two waveforms at the same level coming together. And we need to adjust the bias, so having them both at the same level is the 10 kilohertz signal at the same level is handy. But you must do the bias at a lower level than the operating level, and most manufacturers say 10 dB, doesn't matter whether it's V's or U's, 10 dB lower than the operating level. So if I go back to my kit here, I'm adjusting that. I have -8 on here. Using my dB controls, I'm adjusting this down to -18. And it's 18 dBUs. If this unit was -10 dBV, I would drop it down 10 dBs, -20 dBV. We do that because we want to do away with the distortion, potential distortion aspects that can come in when we are adjusting the bias. So, bias, what does it do? Why do we put it on there? This is a diagram here with no bias coming in. There is a thing down here, which I'll just pop on the larger screen for you, the magnetic transfer characteristic. It's kind of this wavy brown line. Do take a note of that. But you can see here, we are feeding in at the bottom our signal here. That's the signal going in. With no bias, we get this distorted signal, this kind of saggy bottomed distorted signal at the bottom, coming out onto the tape. And the reason behind that is it's called coercivity. Longish word, and I've just managed to pronounce it correctly, but basically it's because the magnetic particles on the tape need a big kick to get them going, to turn them round in the angle that we want them to. And without bias, there's not enough kick, there's not enough grunt in the recorded signal to give those particles a kick around. The result, we get this distorted signal. So someone thought, I know, as an idea, let's try and move this recorded signal up to this flatter part of this transfer characteristic curve here. Don't just accept it, that's what they decided. So they thought they'd try DC bias. Notice the signal's now moved to a flatter part and we've got no distortion. It's a nice smooth waveform. The downside is, if you can read that, there was a lot of noise added to it. Somehow, and there's a lot of myths go on in the world of tape machines, someone discovered, you know, they tripped over, they fell over their coffee or something and it put AC all over the machine. I don't know. They discovered though that if you put AC bias onto the wanted record signal, the audio comes out pretty much pristine. We are putting a signal in at the bottom here. We are mixing a high frequency signal with it. And notice now, look at the red signal. It's in the linear region at the top there. That's the one we want. There's also a ghost signal at the bottom in blue. Don't worry about that. It magically disappears due to the action of the tape, the record head and all the electronics. And you've got this big bias signal in the middle. Again, I'll just skim over this because you shouldn't need to adjust it for an audio lineup. And a general audio lineup, but you'll find a control on the machine called bias traps. Don't worry about those, and I strongly urge you, unless the machine, the record boards have been worked on, don't touch the bias trap. It's to do with getting rid of, it traps the bias, it gets rid of the bias. Follow the manual if you've inadvertently done it to change the bias trap, but on a general audio lineup, when I would do routine machines for the BBC way back in the 1980s, 1990s, we never touched the bias trap. We assumed it was okay. The oscillators on modern electronics, and I class those from sort of like late 80s onwards, are fine. The oscillators are stable, and so you won't need to worry about it. Earlier valve-based machines, it's a different ball game, and you might find you do need to look at the oscillators and bias traps as a requirement. But the result is we get this high frequency signal. Downside is that for bias, if we add bias, it can affect the distortion. The ideal amount of bias is for least distortion is lots of it. It's small distortion for maximum bias. The downside is you have maximum bias and you start affecting the high frequency signals of the tape machine. They do a thing called self-erasure. They start getting wiped off as fast as they're recorded. I told you there's lots of physics involved in this. So we need to do a trade-off in how much bias we add. And this is a term you might come across and you'll find it in the manual called overbias. And this is overbias. At 10 kilohertz frequency, this is what we are injecting into our machine as an audio signal, and there's bias being mixed into that. As we add the bias in with the control, we are actually turning a 10 kilohertz signal up. You'll find the 10 kilohertz level starts to go up until it hits a peak. And it won't go any further. You keep turning the bias up, it goes over the peak, known as peak flux, and then comes back down to a signal what we set called the overbias level. 10 kilohertz at the bottom, turning the control up, gets to peak flux, keep turning the control up, it drops over the top. And how much we turn it over the top is the overbias. And that figure, fortunately, we can just talk about dBs, can be anything between, say, 3 and 6 dBs for a tape at 15 IPS per second. And that's the thing you must also look at now. You must look at the manual to tell you how much overbias. You must know what speed you're in and also the type of tape you're using. RTM very nicely publish all the tape specifications for their tape. I've saved them all on my laptop. I know for a fact that most of them require 3 to 3.5 dBs of overbias. So that figure there is I carry on turning the control until this top figure drops. Doesn't matter how many volts it is, it doesn't bother me. I just turn it down by 3.5 dBs. Some other tapes need 4 dBs, some need slightly less, but 3.5 dBs is fine for SM468, 900, 911. That's their overbias figure. If I was going at 7.5 IPS, I'd add another 3 dBs onto it, so I'll drop the level down as the speed halves by another 3 dBs. dB. So I add 6, more double that, 6.5 dBs of overbias. Similarly, if I was recording at 3 3/4, which I don't tend to like lining machines up for, I'm winding in 9 dBs of overbias. We'll wind it round the other way. If I was recording, lining a machine up with RTM 911 tape, and I was running at 30 IPS, I'd only be putting, say, about 1.5 dB or 2 dBs of overbias in. And that means we've got a compromise been worked out by the tape manufacturer, and the tape formulation has been taken by the tape machine manufacturer way back when they designed all these machines. And for the electronics they've designed, what is the best compromise of how much overbias you do. So I'll just demonstrate the overbias to you. Let's go back to our tape machine. Let's put their machine into record. Go back to our kit. I'm now got minus 18 dBs at 400 Hertz. I'm going to change that to 10,000 Hertz. I then look at my control panel, look at what tweak I'm doing. This particular one, very handy, it's known as bias for the particular channel. You are adjusting the bias per channel. So if you've got a 2-track machine, tracks 1 and 2, or tracks left and right, 24 track, tracks 1 to 24. You need to repeat it 24 times. If I just go down to the control here, it's currently at minus 19. I'm now going to turn the bias out. I'm winding the bias out. So I'm going back over that hump, and you will find there it is. The bias is all gone. I've taken the bias out, so the HF has virtually disappeared. I'm now going to turn it back up and find the peak. So we're going over that peak. Yes, the waveform will wobble about a bit. I'm not interested in what level it is at the moment. I'm doing everything relatively. So I'm keep turning this up, I'm keep turning the bias up, and I'm going to find the peak. There it is. So I'm winding the bias back in at the moment. It's at minus 17, keep going up. I'm finding the peak. It is at minus 16.3 dBs. Let's call it minus 16 dBs. I carry on winding it in, and I'm going for minus 19 because I want to take 3 dBs of overbias. I know that Agfa Pen 468 for this machine needs 3 dBs of overbias. So it now drops out from minus 16 down to minus 19. And you're repeating that for each channel. Once we've done that, you then need to go back to our record chain. We're down here at the bias, we've done that. You then need to check your level again. You have actually worked, although we're working on 10 kilohertz for the bias signal, it will affect all signals. So it's best to go down, put your nominal signal level in, minus 8 in this case, perhaps even do it at minus 18 and then wind it up to minus 8 or whatever your nominal level is, to make sure that the level you put in is the level you're getting coming off the tape. You know the replay levels are okay because you've adjusted those. It's only the record side you're working on to get the level. Repeat the same with your frequency check. Do your bias first, then do the frequency, because as you saw, the bias does alter the HF response. As I wound it in, it took the level in and out. Repeat it with another level check because you're making changes with the amplifiers. And then finally, have a listen. Put some music on that you know, of a known source. Put the machine into record, listen off tape, and then flick between the source and tape if your buttons, if your machine allows that. And what you are listening for is you don't want any level jumps between the two, i.e. up or down, dB increase or dB drop. Listen to the highs and lows again, just as we did with the replay test. Listen there to make sure that the response is the same. You're also, or the frequency response is the same. Are all the highs there as you expect them? Are all the low frequencies? You're also listening for things like distortion, especially if you're playing perhaps like a female voice singing or a violin, something that's very, very percussive sound, maybe a crash of a cymbal. Is it distorted? All these things you need to take account of. Again, as I said, with the replay side, if they're not to your satisfaction, there's a big difference between the record and replay. A big difference. Sometimes there are minor differences, even at 15 hips. You know, the HF is a little bit down, but I know it's the tape. I'm going to have to go with that and the age of the machine. But if there are big differences, go around the loop. You might even have to go around the loop and do the replay lineup again, just to satisfy yourself you are in the right area. You've adjusted the machine correctly. So that is basically the essence behind an audio lineup of a tape machine. AV Resilience is my professional audio company. This is what I use for, I put the basically non-tape business through, which is microphones and other professional audio solutions. Real Resilience, as you can see there, that's the website. I hope you found that by now, and the various other contacts. Obviously that's a UK phone number, and I'm more than happy for you to call it within reason. Please try and keep it to 9 to 5. I appreciate we've got people from all over the world and allow for the time zones. But the other way to get hold of me, especially, is via Facebook and the Facebook pages, and leave a message there.